Let's look at the density of some metals. So I'm getting a little lab notebook set up. I would love for you to do this as well. You could have this be a notebook that you use for, all of your stuff and keep it all together, a separate lab notebook, whatever you like. I've been having you do stuff on pen and paper, and labs in particular, I think is really great. So it's a good skill to learn. If it's the worst idea in the world for you, don't bother. But this is what I recommend. So we're going to do our density of solids lab. We are going to look at a couple of things with some metal samples. Okay, so I have a little bucket of metal samples here, and I know exactly what they are, but I'm also kind of afraid I don't. I'm afraid they might be something called alloys, which means they're a little bit of a mixture. So I want us to find their different densities and see if they're as pure as I think they are. So that's the way we're going to run this one this time. Purely a, kind of a quality control sort of a lab, okay? So we need to gather the mass of all of our samples. In addition to that, we are going to need to measure the volume of our samples. We're going to look at specifically how we're going to deal with getting volume of these samples when we dig into our data collection. The second part of what we're going to be doing with this lab is playing with some graphs. So we're going to need to think about how do we use graphs for determining density and other things. So here we are. This is what we're going to do, right? So we're going to need a data table, right? So let's make a data table. So on our data table, we are going to need to record mass and volume, right? And we're going to need to do that for multiple pieces of metal. I'm also going to need to get the volume measurements, and I'm going to want to take multiple trials of that. All right, so we are going to use some titanium. We are also going to use some stainless steel. Some aluminum will find its way in there as well. We're also using nickel and a copper chromium alloy for the second part of the lab. So please go ahead and be filling in your data as you go. Again, you can skip ahead and just fill in the data table if you'd like, but I am trying to let you see all of the data collection happening live and in person. And you will see a difference from this data table and the one I show you in the end, because in the end, I've added 2 more samples of that copper chromium so that we can do that other part of the lab. So to get the volume by displacement, we're going to need to measure both the initial and final volumes of water before and after we add a piece of metal. Sample will be submerged, but not so much that it's going to overflow. And for me, I'm really wanting to keep it in the camera view. So I don't know how much is in there. I just kind of dumped some in. What I do need to know is exactly how much water is in there, right? I don't care what amount I started with. I just have to make sure I record whatever that amount is perfectly, okay? So we're going to look, and this is your first lab lesson online. It's interesting. And we are going to see that the water, right, is right here, right at that little curve there. That's called the meniscus. So when you read a graduated cylinder, you must get your eye directly to the bottom of that curve, that meniscus, and that is in fact where you read. So if I'm looking at these numbers, I see 20 milliliters. The tick mark between 20 and 30 would be 25. So that makes this 26, 27, 28. But it's not right on 28. It's a little above 28, but it's below 29. So I am going to estimate that next digit as a 5. Call it half, right? So we'll call this 28.5 milliliters. Right? Then I put my sample in. So I'm working on titanium. That's where I am in the little notebook. So I have a little metal sample here. Since this graduated cylinder is glass, I'm going to be real careful with how I add these metals. I'm just going to let it kind of slide in. We're going to hope we don't break anything. All right. So my sample of titanium is in there. This is the same one I weighed. And now we're going to read that volume again. So when I look, I see it is above 30. It is, I would say it was right at 31. So the number I'm going to write down is 31.0 milliliters, right? I'm still going to state that next number. That is your job. When you are reading an analog device, so a graduated cylinder, a thermometer, anything where you're reading tick marks, essentially, it is your duty as the scientist to estimate the next place in your number. That is what is expected of you. So anytime I read a volume measurement, I assume that that last digit is uncertain, okay? So that's where I am so far. This is my first try. Now, gotta get it out of here, so I'm gonna dump it out, and I'm gonna do it one more time, right? So why do we repeat experiments, right? Why is it that we feel the need to do it again? So anytime you are, a human, you don't do things perfectly. Like just period, anytime, all the time. It just is that way. So there is an inherent amount of error in everything that we do. And there's a level of that we can literally not fix, right? It's just always going to be there to some extent. But what we can do is we can eliminate that error's impact, that random error. We can eliminate the impact it has on the results we get, on the findings we find, by doing multiple tries and then finding average values, right? So if you do the same experiment again and again and again and again, the chances of the random errors all being the same every single time are very, very, very small. So what's actually going to happen is that you are going to instead have them kind of average out. Because if it's random, sometimes it'll be a little high, sometimes it'll be a little low, whatever. So multiple trials, find an average, and you get a more realistic number. It eliminates the effect of those random errors. So if you want more practice looking at values and measurements, go ahead and keep watching the entirety of the rest of this video. I am showing you in double speed at least all of the measurements that I took. They're all here. That is what makes the video so very long, even at double speed. So please, please, please skip ahead to the data table if you would like, but if you want a little more practice seeing about reading these volume measurements, go right ahead. And I will see you in a few minutes when we hit the data table. All right, now that we've collected all of our data, you can see it here in the data table. Feel free to pause to get down any detail that you're missing. Now, what are we going to do with this data? To process the data, you're going to look at this in two different ways. You're going to take the first set of data, all of the metals except for the alloy, and you are going to utilize those, and you're going to use the equation D equals mass over volume, right, to get density. So you're just going to go through, calculate the density for each and every one of those trials, average the two trials that were for the same sample, and then you can report out on the densities of those metals. I want you to get on Google, look up the known values for the densities of those metals, and compare the two so we can see if these samples are pure or not. The other part of the lab that I want us to do is to play with some graphs. So you're going to take the data for all of the copper chromium samples, the 3 different samples, both trials for all of them, and you're going to plot them on a graph showing mass versus volume. Then you're also going to look up the density of both copper and chromium. You're going to assume that you have 2 samples of each, one that is 10 grams and one that is 20 grams, and you are going to utilize those assumed sample sizes and the density that you looked up to figure out the mass that they would be. Then go ahead and plot that data as well. So plot the mass and volume that you come up with there on your graph also. So your graph is going to have a lot of data points. Then you're going to go ahead and add that line of best fit to each of the 3 sets of data. One set of data is the copper, one set of data is the chromium, and the third set of data is your measured data, and that's for the copper chromium. We're going to be able to use this graph to consider what do we think the composition of that alloy is. Which of those pure elements, copper and chromium, does it have more of? So just to recap, you're going to take this data, you're going to do some math with most of the metals, you're going to save those alloy pieces to make a graph, you're going to do some Google research, and in the end, you're going to make a little report that tells me, 1, does it seem like most of those metal samples are pure or not? And 2, what do you think the composition of that alloy is? How much copper and how much chromium? And we're looking at a ballpark figure here, so don't stress the exactness of that too much. We don't really have any way of knowing that exactly right now. All right, good luck.